Hi guys, and welcome to the next video. Today we're going to take care of the group inputs and outputs. That will be a topic following the digital inputs and outputs, so let's get started.
5, 7, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0.
Alright, so let's do a little bit of a theory before we get into the exercises, so you actually will understand what a group input or output is. So the group inputs and outputs are used to store a number, because sometimes you want to communicate with the PLC by sending a number to it or receiving a number back. Now the important thing about the group inputs and outputs, they can send only digital decimal values. So not decimal but decimal values, sorry. So that means you can send only a number but not a real number. That means you can send number 10 but you cannot send number 10.5. So then it becomes a bit tricky to send real numbers through group input and output, but this maybe we're going to cover later on. You need a little bit of math to do it. It's doable. Also, you can send and receive only a positive number. So the digital group inputs and outputs cannot send or receive negative values. In order to do it, you need an extra bit saying the sign, is it positive or negative, and you need a little bit extra math to use it later on. So basically the value you're going to get on a group input and output, you're going to multiply by -1 if you get a certain bit. This way you're going to get positive or negative value. Okay, but where do they come from? How do we assign them and why do we have them? So let's start with the where do they come from. Basically they come from your digital inputs and outputs. So what the group is, basically it's a group of inputs and outputs, and you change their representation to a binary. That means depending on which bit you will take a look at, you're going to get a different number. What does it mean? It means that you are going to use the 2 to the power of x, and this is going to convert your input to a number, giving you a binary number. So an example of a binary number is 1001. Now remember that the binary are, when you read them from the left to right, the left is the highest value, the right is the lowest. So if we're talking about 1000, that means that the first number on the right will be your bit number 1, then bit number 2, bit number 3, and bit number 4. And your first bit is going to be 2 to the power of 0, your second bit is going to be 2 to the power of 1, your third bit is going to be 2 to the power of 2, and the fourth, is going to be 2 to the power of 3. And that's how you're going to convert it. So basically you're going to see, okay, I'm not using number 1 because it's 0, I'm not using number 2 because it's 0, I'm not using number 3 because it's 0, but I am going to use number 4 because it's equal to 1. So I need to convert this to a number. So then you see, okay, it's bit number 4, and it's 2 to the power of 3. That gives us 8. So the value I'm going to send is going to be equal to number 8. That's how the binary works. And it applies to all of those. And you can send, just like with 0 and 1, you can send the value of 0 on 1. That's if you use just one input. If you use 2, then you can send 0, 1, 2, right? Because you have, or 3, because we have the 0, 1, we're going to use with the first bit, then with the second bit, we can send 2 or 0. So if we're going to send 0 and 0, it's going to be 0. If we're going to send 0 1 and 0, then we're going to send number 1. If we're going to send 0 and 1, we're going to send value number 2. But if we're going to send 1, 1, we're going to send the value number 3. And that's how the digital input and output work. They are just going to translate the digital value from your digital inputs or outputs to a number using a binary translation. So that's pretty simple, I hope. You can train it, you can try it on the paper, and then we're going to try it on the robot, on the exercises. So let's get to the exercises. Hi guys, and welcome to the exercises. So today we're going to talk about group outputs. So first, let's get to the group output menu. We're going to do that by hitting menu. Then we're going to go to I/O. So basically the same as we did previously. And then we're going to select group, and we're going to hit enter. Alright, and we're in the group input or output menu depending on what was selected before. As you can see, I'm right now in I/O group out, which means those are group output, the number, is it simulated or not, value, and the description of the group output. So pretty much the same like in our digital inputs and outputs. Let me just show you so you can compare. As you can see, it's the same. The difference is only here we have GO and here we have the group out. In here we have the digital out and we have the DO. So as you can see, everything looks pretty much the same. Like in the digital outputs, the only difference is those are group outputs, and instead of just 1 or 0, we're going to get some values in here. Okay, let's go back to our groups. Okay, the same as in the digital inputs and outputs, we can switch between in and out by hitting the in and out button right here, or there's a F3 button on your pendants. When you hit it, you're going to be taken to group input. Okay, what are the options here? So the same config, we're going to talk about this soon. Then we can simulate it. So the same thing as we did in the group, in the digital input and output video where you simulate it, and then you can assign a value to an input or output. Here we have the unsim. When we hit next, we have the same options where we can sort it by the number, so by this, or we can sort it by the comment in here, and then we have the detail and help. So let's go one by one. If we're going to hit the help button, we're going to be taken to a help menu describing a little bit about the I/O. So you can read in here. There is more information I'm going to tell you is more detailed, so feel free to check it out. We're going to hit previous to go back. The next button is the detail button. When you hit it, you're going to be taken to this menu where you were able to change the comment, and you can go to the next one or previous input. Group outputs. When you hit the next one, it will be automatically taken to the next group output, and so on and going back. When you hit the previous, you're going to be taken back to the original screen. Okay, when you sort it by comments, again, you're going to go by letters, so it's going to go from A to Z, and it's going to ignore the numbers because you set it to sort it by the comments. If you hit here, you're going to get it commented by the numbers, so again, by the number, probably that's the most common sort that you will see. Okay, when we go to the next, and we can go to the inputs, and again the same rule as we have in digital inputs. The inputs cannot be set because that's something that's going to the robot. Outputs are something that goes out of the robot. So if you're trying to assign a value here, it won't allow you because you cannot set the value to an unsimulated port. What does it mean, guys? Nothing else than that just fact that you gotta simulate it. So you gotta hit simulate, and right now you can set a value in here and it will stay because that's not something that's coming to the robot. that's something that you simulate. Okay, to unsimulate, of course, we're going to hit unsim. Alright, there is one more option that you can use in here. It might be useful for you, it might not be useful, it depends. So when you go to the number, as you can see, we have an extra button called Format. What does it mean? That means you can change the representation of the number. So you can go from the decimal to hex when you hit this one. And you have it in the hex value. Maybe it's useful, maybe for example your device that you will be communicating with is using a hex number, and that's going to be easier for you to see. So it doesn't affect anything, it's just the way how you see it, either as a decimal number or as a hex number. Okay, so that's pretty much it about the group input and output, just by reviewing it. Now let's talk how do we configure them. So we're going to configure them pretty much the same as our digital inputs and outputs. So when we go to the config, you're going to see a few things here. The new thing in here is this one. And let me just show you the I/O, so you will refresh your memory from the latest video. And as you can see, it's pretty much the same. We have the rack number, we have the slot number, we have the start number, which is this one, and that's new. Those things are not used in the group. Why is that? Okay, so basically what is a group? Like I said in the introduction, it's like a group of inputs. So basically what you want to tell to the robot is how many inputs are you going to use to set the value in specific group output. So let's go in here and let me show you. The group output number one, let me go back to the monitor. So the group output number one, the manual style, has 8 inputs that are going to be used to set a value in there. That means you're going to use 8 digital outputs to set a value to this group. So this option in here is basically saying how many bits are you going to use to send a number to a group output or receive a number to a group input. So the same as in digital output, the rack is going to be your device that you're going to use as your input or output in this case. The slot is going to be the slot, so the place that you stake in the card, and those are the two new things. So remember, like we spoke about the start number in the digital output, in here that's going to be, I think, explained a little bit better. So a start number is the offset, guys. So basically we're saying, hey, I want to use the device number 89 located in slot 1, but I want to start counting from number 25. So that's the offset. And then you'll say, okay, I will start counting from number 25, but how many numbers should I count in order to set a value to the group? And you're saying 8. So that means you're going to start counting from number 25, and you're going to count 8, and that's going to be all of your out bits, all of your digital outputs that are going to be set to this group output. Alright, so let's see how this works. First of all, you gotta locate where that is. So how do you locate it? You go to the digital outputs, because group output are going to match digital outputs, and you're going to take a look. Okay, I'm looking for rack 89, I'm looking for slot number 1. Alright, so what do we have in there? Okay, so rack number 89 and slot number 1 are the I/O range from 1 to 512. Okay, that means that I'm going to use that group output number 1 is going to be located within this range. Okay, but where is going to be the first value of that group output? It's going to start at number 25. So what are we going to do is we're going to go to this range. It starts at 1. We're going to count 25. So we're going to go number 25, and we're going to count 8 bits that are used in this group. So this is the first one, the second one, the third one, fourth, fifth, sixth, seventh, and number 8. Okay, let's check it. Let's go to monitor. Let's turn all of them off. And let's see. One more time. The first one was number 25. And the last one is the 8th start that you start counting from 25. And this is going to be 32. So when we hit in here, in here, when we're going to hit on number 25 on, we're going to see our number 1. And then as the binary go, when we turn on the second one, we're going to hit 2, number 4, number 8, number 16, 32, 64, 128, and the next one is not being used because it will be the 9th output, and that's not assigned to a group. So guys, that's how things are assigned. So you're going to take a look what device you're using, you're going to match it with your digital output, and then you're going to count how many outputs you want to offset, and then you're going to say how many you want to use. Okay, maybe that's not clear totally how this works. Let me show you on a real example using registers that we already know. So I created a program called group in here. And basically what does it do? I'm going to show you how the bit representation works. So you can imagine whenever we're going to turn an output, we're going to get a value to a register. So basically our register number 205 is going to be the results of the bits we're turning on. And remember, like I said in the introduction, the bit number 0 is basically 2 to the power of 0, and that equals 1. Bit number 1 is 2 to the power of 1, and that equals 2. Number 3 is 2 to the power of 2 equals 4. Bit number 3 is 2 to the power of 3 equals 8. And then we're going to get the results when we sum all of this up. So in our group output, which is going to be a register now, I'm going to simulate the group outputs on the registers right now. Let me put the 3 windows here so you can actually see. Okay. Okay. So I'm going to turn all of them off. And remember, like in the group output, right, when we set the first bit on, we will get a number 1 on the group output. So when we run this code, I'm going to get output number 1, and as a result, so sum of all of the outputs, I'm going to get number 1. If we turn the first one and the last one on, we should get number 8, because 2 to the power of 0 is 1, 2 to the power of 3 is 8, so this is our bit number 1, bit number 3. When you sum them up, you're going to get a value of 8. I'm sorry, of 9. 1 plus 8 equals 9. And the same apply to other values. So let's say we want to get 5. So in order to get the value of 5, you need to turn on the number 4, because 2 to the power of 2 equals 4, and number 1, because 2 to the power of 0 equals 1. 1 plus 4 equals 5. So we're going to turn on output 0. We're going to turn on output number the bit number 2, because that represents 4. And when we run the code, we're getting number 5 as a result, because 1 plus 4 equals to 5. So that's how the group works. I've just shown you this on the registers, so maybe it's a little bit more clear. So basically, a group is going to sum up the digital outputs, and it's going to make number out of it. So let's right now assign our small logic that I created in here, the small program, to a group. And this way we're going to know if I'm right or I'm wrong. Let's go again to the group. And let's say we want to assign it to group number 10. So we're going to hit config. And first thing we need to see is like on what rack are those outputs that we want to assign to a group on. So like I showed you before, we want to assign from 129 to 132. So we want to assign 1, 2, 3, 4 bits. Okay, first let's locate the range. So we're going to hit config, and you can see that output 129 is located in this range. Okay, that means we need to use slot rack number 89. So we're going to go back to our group output. We're going to put 89 in here and hit number and hit enter. Okay, the next question is, what slot is it? What slot is it? It's slot number 1. Okay, so we're going to say we're going to use slot number 1, hit enter. The next question is the start point. What is the start point? The start point is what we've said we wanted. It's 129, because the 129 is the first output that we want to use in our group. Okay, so the first one is going to be 129. We're going to hit enter. Okay, the next question is, how many bits do we want to use to represent this group output? In our case, it's 4 bits, right? It's 129, 130, 131, and 132. So 1, 2, 3, 4. So we want to use 4 points or 4 bits to represent it. We're going to hit number 4 and hit enter. And our group output is configured right now. So we're going to go back to monitor, but as you can see, nothing is assigned to here. Why? Because we need to cycle power to apply the changes. Before we cycle power, I'm going to give a name to it. So I'm going to hit detail, enter. I'm going to go to options, use keyboard, and I'm going to set 4 points. Okay, let's go back, let's cycle power, and let's see if it works. Okay, so the robot is restarting right now. The same rule, guys, is going to apply to the group inputs. It's going to be exactly the same. You will configure it in the same way, where you assign your digital inputs to a group input, and that's how you're going to get the values. All right, the robot is booted back up. Let's turn on 3 windows. In here, let's do our digital outputs. Group outputs. And as you can see, now we have the unseen in here. We have the value in here. We have our name. Let's see the config. Okay, we have from 129. We have 4 bits that we want to use. Outstanding. Let's go here. Let's turn on the registers. I was using the 205 as the result in here. And in here, let's do IO, digital, and let's go to 129, which is the first output. Okay, so right now when I'm going to turn this bit on, we should get a value of 1 in here. Boom. When I turn this one on, we should get value 2. Boom. When I turn this one on, we should get 4. And with the last one, we should get number 8. This one is not being used because we use only 4. I am correct. Okay. So right now, we can run the code, the one that I showed you, and you can see, compare the value of the group output with the data registers. I gotta hide this window, but let's turn on bit number 2, so we should see the value of 4 in both data registers and the group outputs. So I'm going to switch to group outputs here. Let's select our group. Let's run it. Okay. We got 4 in here, we got 4 in our code. Why? Because like I explained, guys, we use bit number 2, which was the digital output 131. As you can see, it's on, the rest is off. So it was 2 to the power of 2, that equals to 4. So group output is equal to 4. Our result is equal to 4. We can try any other combination. Let's turn on a few of them. So we're going to go to 129. I'm going to turn on, let's say, bit number 1, bit number 3, and bit number 2. So we got 11 on our group output. Let's run our program. We should get 11 as a result in here. And why we got 11? Because we have the bit number 1 on, bit number 2 on, and bit number 4 on. And we have 1 plus 2 plus 8 equals to 11. Okay, guys, that's how we use the that's how we configure the group outputs. Now, how do we use them in a program? So let's create a program. Let's name it group 1, and it's pretty simple. So the same as inputs. You can do instruction. I don't know why I keep saying insert. I think like the first time I've seen it, I just thought it's insert, and I keep saying insert. It's actually instruction. You want to go to I/O. You want to hit enter. And in here, instead of using our digital outputs, we're going to use our group output. So we want to hit enter. And the one that we used, so we want to assign something to number 10. And we want to assign, like, let's say, constant value, and let's assign number 8 to it. So how this works, guys, is actually opposite. So now, instead of turning on the I/O, let me go and show the I/Os in here. So instead of turning a single I/O, and by this getting a number, when we run this code, we're going to see number 8 on our group output, and it will automatically turn all of the I/Os on. So let's run it. And as you can see, we got number 8 on our group output, and we turn on the correct digital output to be sent to the PLC. Now, when we turn all of them on, the maximum value we get is 15. What is going to happen, guys, if I put 20 in here? Let's see. Okay, so I want to send the number 20 on the group output, but I didn't. Why? Well, guys, this is because the maximum value you can send out of it is number 15. Let's see a different number. Can we send 25? Of course we cannot. So guys, you need to remember what is the maximum value that you are allowed to send through the group output. Because if you send more than require, or than the output can handle, you are going to get wrong results in here. So remember, the maximum value was 15 because we're using just 4 bits, and that will work fine. As soon as you put a higher value to it, we are not going to get a good result because we cannot send that value. Now, the other thing I want to mention is we cannot send real numbers. We can send just decimal numbers. So everything from 0 to whatever value. Actually, the highest value you can set is a double word. So that's 32 bits. But again, it depends how much you wanna send. You can send as well negative numbers. Excuse me. And you can receive negative numbers, but this is a little bit more tricky because you gotta use a sign bit in order to do it. And as you can see, if you just want to send a negative number, it will not work. So you got to work on it. It's a little bit more harder. I'm not going to go through it right now, but just to give you an idea, is you're going to send number 5, and then you're going to send extra bit in here saying if it's positive or negative. Alright guys, and that's all from the exercises. Thank you. Alright guys, I hope you enjoyed that video. Don't forget to like, subscribe, leave your comments down below, and like always, see you in the next video. Bye bye!